David Mohammed, and I'm here to talk to you guys about autotune. What is autotune? Autotune is a pitch correction software intended to allow one to correct minor pitch errors in digital inputs of speech and music. The sound that started the autotune revolution. In 1989, the musician Cher released a song titled Believe, which depended heavily on autotune techniques that produced a unique vocal sound. Here's an example. Do you believe in life after love? I can feel something inside me say, I really don't think it's strong enough now. After the release of that song, musicians around the world were looking for this new technology that could correct or change a singer's voice to a perfect pitch.
Okay, so how does it work? Well, first you need a continuous signal. The continuous analog signal is sampled. Then the sample signal is quantized. Then lastly, the quantized signal is then digitally coded where it can be stored in the memory. Once the signal is processed, the information contained can then be displayed, analyzed, or mathematically manipulated. The input signal must have minimum distortion before analyzation and manipulation can take place. This helps with the quality of sound recorded, and also it helps determine the timbre, which is what makes one instrument sound different from one another, even if they play at the same note or volume. Okay, now we move into pitch detection, understanding pitch and how it relates to digital audio functions. Pitch is determined by a period at which the waveform repeats itself. The number of time a periodic wave repeats in 1 second determines the frequency of the pitch. For this reason, autotune will not detect the pitch when the input wave is non-periodic. Okay, next is criteria for evaluating pitch detection. The first one is accuracy in estimating pitch period, accuracy in making a voice or unvoiced decision. Third, robustness of the measurements. The fourth, speed of operation. The fifth, complexity of the algorithm. Sixth, suitability for hardware implementation. And lastly, cost of hardware implementation.
Now the method for pitch detection. They have several approaches for detecting pitch, so here are some. The time domain approach, frequency domain approach, spectral approach, fundamental frequency of speech approach. It's inclusive on which approach does autotune take. An example of a frequency domain approach. First, the windowed frame is taken into a frequency domain and the magnitude of the spectrum is calculated on the left. Next, the spectrum is downsampled to create more compressed versions of itself in the center. Notice how the higher harmonics of the frequency aligns with each other in the downsampling spectrum. Lastly, a multiplication of these spectrums is performed and the maximum is found on the right. So in this graph, it shows the relationship between the input pitch in red and how it relates to a specific note in blue, depending on the scale. Sound studio implementation. In a recording studio, each instrument and singer is often recorded in an independent audio track that can be then manipulated later without influencing other sounds. In this way, it is possible to completely remove a singer or a guitar from a sound without influencing another voice. Autotune precision. Autotune analyzes a waveform in order to determine the pitch, and then it will correct the pitch by stretching or compressing the periodic waveform. Lastly, it will regenerate the desired pitch. The precision by which autotune corrects the pitch is extraordinary. At a frequency of 400 Hz and a sample rate of 44,100, autotune digital signal processing algorithm computes the pitch to a accuracy of 1 times 10 to the minus 4 samples per cycle, or 4 times 10 to the minus 4 Hz. Additionally, autotune was designed to detect and correct pitches up to 6C and as low as A0 or 55 Hz. Okay, So how auto-tune corrects pitch. Auto-tune changes the instantaneous pitch and introduces no distortion to the final output. It does this by using the same basic computation used in samplers to retune samples. This is different from other pitch shifting algorithms which put noise in sounds as a result of fast Fourier transform, overlapping, and saved algorithm base error. In the worst case, a continuously varying tone can be corrected to within an error of at most one cycle in 80 seconds. These accuracy are equivalent to 0.01 cent, by which the various scales of the automatic mode discussed below are initially specified. So in this example, we have a periodic waveform. The original signal is in red. Prior to the recording, the required note was supposed to be sung at D3, but we can see that the pitch is slightly off. So auto-tune software corrects the pitch to D3 while still maintaining the singer's tone of voice, which is the key to success for this program. So from the previous example, we see how auto-tune simply changed the pitch of a singer's periodic wave. But in real life, this procedure is very complicated. Auto-tune software is based on a physical principle of music production, physics of hearing, disciplines of modeling, filtering, linear system theory, estimation theory, numerical analysis, calculus, and music theories, and other disciplines. All all form the basics of auto-tune and how it works. So this automatic mode is where you can preset your own scale choice, return speed of sound, and add or remove vibrato. It's a fast way to quickly analyze your periodic wave and output your desired pitch. Okay, so now this graphical mode is where you can see your periodic wave on a real-time graph and make your pitch changes by hand. This way is slower than the automatic mode, but if it is done right, you would not be able to tell that auto-tune was used. So here's my final example of auto-tune. Here's a song without auto-tune.
Well, when you think you got it all together, is when you find that it's falling apart. You can't count on the ground you stand on. You're walking around like you're in the dark.
And now here's the same song with auto-tune.
Well, when you think you got it all together, is when you find that it's falling apart. You can't count on the ground you stand on. You're walking around like you're in the dark.
So I hope you could have tell the difference between the two songs. The one with auto-tune was way more pleasant to listen to. So this wraps up my video. I hope it was informative for you guys, and thanks.